Hello, my name is Miguel Ángel Selles Cantó, and I'm going to present the paper that we have submitted to the second Coatings and Interfaces web conference. I'm going to start with the introduction, telling that the food and beverage metal cans market is in continuous expansion. There are a total of 12 steps in can manufacturing, and in 2 of them we apply a polymer layer. So if we use a polymer precoated sheet, we have several advantages like a reduction of manufacturing steps, reduction of time in the manufacturing cycle, reduction of costs. And disadvantages, the more expensive material and there's possible damage to polymer layers. So using this new material can reduce the number of steps in can manufacturing, and a total of 6 steps can be removed. The objective of this research is to study processability in the use of a steel sheet coated with 2 polymer layers and carry out a theoretical model of the optimum process conditions, as well as validate this model with experiments on an iron simulator. If finally viability is demonstrated, it could be possible to produce metal containers without VOC emissions, which is an incremental improvement. And it could be possible to get a greater internal insulation between beverage or food and metal. And we could improve the mechanical properties of the can. The material has been provided by ArcelorMittal and consists of a base of steel coated with a polymer layer called the tie layer with characteristic of maximum adhesion to metal. And over this, there's another polymer layer with characteristics of high strength and good mechanical properties, and also has good properties for friction. I'm going to talk now about the theoretical modelization. Ironing is the most crucial step in a polymer coated can manufacturing, and the variables that we have considered are the material, temperature, die angle, reduction in thickness, and punch velocity. We have developed an upper bound model for successful ironing. Both polymer layers survive to the process. In the saving model, the top polymer layer is saved. We have also created an artificial neural network of the ironing process. This is a short video that shows the ironing of a strip. It's possible to see how the strip passes through the small gap that is between the punch and the die. These are the process variables we use for the design of experiments. The results of the upper bound model show that we have an optimal angle of 4.8 degrees. The surface quality factor is a qualitative factor in which the surfaces are compared to the following ones. And in this graph, it's possible to see the die angle versus the average surface quality factor, and it's possible to see that with angles of 4 and 6 degrees, we get good ironings. And after some roughness tests made to strips, it's possible to see that angles below 4 have great surface. The conclusions. The die angle is the most important variable. Good ironing have been achieved with angles of 6 degrees or lower. Punch speed and temperature have less significance. Experimental results are very close to those obtained with the theoretical upper bound models, and the new 2 polymer layer coating material survived to the most critical step in can manufacturing, which is the ironing process, under certain conditions. And several steps in traditional can manufacturing can be eliminated, which reduces cost and benefits the environment. Thank you for your attention, and we are open to questions.